is example 6 of the Solving Exponential and Logarithmic Equations lab. We have the following equation. We have log of base 6 of x plus 1 minus log of base 6 of x is equal to log of base 6 of 29. So first I'm going to combine these two logarithms. We'll notice that each log has the same base of 6, so we can combine these two logarithms on the left side using the quotient rule. So we have a log with the same base subtracting each other. So we look at the quotient rule. We have two logs of the same base a of m and n subtracting one another. We can combine them as the first one that's positive is the numerator, and the one that has being subtracted is the denominator for log a of m over n. So I'm going to use that rule to rewrite this. We have log of base 6 of x plus 1 divided by x. We have x plus 1 is the one subtracting x, so this one is the denominator and this one is the numerator. Is equal to log of base 6 of 29. So now that we have it in this form, now we have log of base 6 of x plus 1 over x is equal to log of base 6 of 29. There's a multitude of ways that we can now solve this equation. We could transport this and put it into exponential form, and we would get, like for example, we would have 6 from this 6 would be to the log of 6 of 29 is equal to x plus 1 over x, and then we would use the number raised to a log rule of a to the log of a of m is equal to m. So it would just be x plus 1 over x is equal to 29. Or we could use the quotient rule. We would subtract this log from this one and put it equal to 0. And then we would use the quotient rule to rewrite it as a fraction and then take it as exponential form, so if we didn't know that one. But by far the easiest rule to use to simplify what we have now is the equality rule, where we have a log of base a of m is equal to the log of base a of n. So two logarithms that have the same base and they're equal to one another is the equivalence of m is equal to n. So essentially what we're looking at is we're putting logarithm a as a function of m and n. We can simply undo it. So we can rewrite this. Log of 6 of x plus 1 over x equals log of 6 of 29. We can simply undo the logarithms on both sides and just rewrite this as x plus 1 over x is equal to 29. So that's by far the easiest way, but the other ways would work too if you didn't know about that rule. So now that we have that, I'm going to multiply by x so that I get this out of a fraction. So we have x plus 1 is equal to 29x. And now I'm going to subtract this x to this side to get the x's on the same side. So we have 1 equals 29 minus x. Well, 29 minus 1x is 28x. And then dividing by 28 on both sides, we get x is equal to 1 over 28. So we need to check that that actually works in our original equation up here. So if we have x is equal to 1 over 28 and we put it into this x over here, so it would be adding 1, and if we put it into this x right here, both of these logarithms would be positive and they would equal log of 6 of 29. So we are in our domain, and therefore we can use this answer.